The example that we gave was if I was to throw a marker and hit one of you, or try to hit Dave back there, whatever that poster is, with holding that marker back here, for one, it's not moving, and two, it has not done yet with that closet. We remember from last week? It has not collided yet. So we can't have a momentum until that has collided with one another. Okay? So, with that problem that we had last week, go ahead and get that out. I don't have the specific words written out for that, but we had instructed to please write them down, and we would start with that today. I don't think we want to use this eraser. It's a little too wet yet. So what did that problem deal with last week? What did it say? Okay. So it ran into a wall. So once that has come in contact with an object and it has a mass and you have a velocity, we can solve for what? I have a good sense of humor. What is it? All right. So, what are we solving for? Which one? Okay, so we need to find the product first because you've read the problem. Okay? The next thing you should do, and some of you are choosing not to do this. You're making it really difficult on yourself when you are choosing. It's a choice that you're making to not do this. It's not everybody. Okay? So again, if you think that we're possibly talking about yourself, well, maybe we are. Okay, so keeping that in mind, you've read the problem. The next thing you should do is what? Yeah, write down what we know. So in that problem, what were we given as far as the information is concerned? Were we given the mass? Okay, so what was the mass? Okay, 800. Okay, and that is kilograms. Oh, I thought you said 822. Okay. All right. What else do we know? .5. Okay. So, given, oh, I got seconds there. I thought you said meters per second. I was writing down what you had said. Okay, so seconds. You said the time. Time's measured in seconds, right? Final velocity. Okay. Okay. All right. Okay. Now, was that the top problem or for both of them? That was the top one. Okay, so we didn't do the top one. Okay. Gotcha. Okay, so with this bit of information, what can we solve for now? So we've got our mass and since it came in contact, we said we can put that variable in there too, the final velocity. So now we can solve for P, or the product of these two, which is the momentum. So you've read the problem, you've wrote down what you need to know, or what you do know, and then once you get to this point, you just do what the formula tells you to do, which is what? What are we going to do according to this equation with these two variables? Since these are next to one another, you're going to multiply them. So the product then equals, maybe, that one's dried up. Let's try this one. Product equals 820 times 5.17. So what does our product equal then? 14,000. 4,000. Okay. And how would we go about labeling that? And remember, we're not subtracting. This is a derived unit where we put them together. It's kilogram per meter over seconds. Okay. So that was the top problem. Okay. So who has the next one wrote down? Who actually wrote it down? P stands for product. It's the momentum. The P just stands for product of multiplying the two together. So P is momentum. It could be pressure, and it could be power. So you need to later on write the variable how you feel the most comfortable, which means perhaps if we were solving for power, you would do this. Put a P with a line like this over top. And if we're solving for pressure, maybe you'd use a P with a zigzag line. Okay? So you're going to use multiple variables. You don't have to use the variable or letter P. You could use X. You could use B if you wanted to, but anything to stand for that. That's what a variable is. Okay? So that second problem, well, let's back up. Does anyone have any questions over this one? And is it possibly one we don't know what to ask? Is that possible? Maybe yes, maybe no. But left outside, are we on the bus? Left middle, middle, right middle, right outside. Okay? Some of you maybe aren't quite comfortable yet. It might take a little more work than what you are maybe used to doing. Okay? Whose paper can I use? Who has this next problem wrote down? Okay? I come back here initially. Don't tear it out. I just want to see it. Okay? You. Okay. So now we have just a little bit of information that is changed because it says the same bowl charged has changed directions and in 2.1 seconds ran into the same wall. The momentum, however, was 3,427.60 kilograms dash meter over seconds. how fast was the bowl moving initially? Okay, the mass of the bowl is still the same. The acceleration was 1.1 meter per second squared. So how would you know that that last number was an acceleration if it did not say acceleration? Because it's meters per second squared. Okay, it's that type of label. Are we going to make mistakes with that? Yes, we're probably going to. Okay, it's one of them things to where we say the same thing. We don't want to repeat them, and we want to learn from those mistakes. Okay, so in this problem, okay, so we've read it, okay, the next thing you should do is what? And make that a habit. What should you be writing down? Yeah, the information that we know, because this is a two-step problem. It's one where you have to solve one variable and write that into a second equation to solve for that. That's why we said get into a good habit of writing down what you know. And for those of you who were choosing to do that or choosing to do these problems, you might be a little further ahead. And if you're not understanding these problems, you've got ample opportunities, many opportunities to help yourself out. Whether that's come talk to myself, we're available before and after school. You have upperclassmen that can help you with this. There's even other teachers that can help you with this. There's classmates that can help you with this. And there's also this video online to maybe go through and read that problem. Because if you're just writing everything down that we're doing and say, well, why did we write this variable there? Well, if you have questions about that, you can go back and watch the video. Okay, so the mass was still the same. So that's 820 kilograms. Okay. Okay, then we know the time was 2.1 seconds. Okay, and that 3,427.6 is what variable? If it's labeled in kilograms dash meters over seconds, that's a label for which one? No. Momentum. Yes. Okay, we got kilograms dash meters over seconds. That is our P variable or our product standing for momentum. So we've got 3,427. Okay. So what other variable do we know? We know the acceleration. Okay. Do you think there's some other information that we have or that we could find or that we need? We need to find the final velocity. Okay. And what's the question ultimately asking? What was the initial velocity? So we don't have either one of those. Okay? That's a question mark, and so is the initial velocity. Okay? Thank you. All right. So this is where, when you write all this information down, now you don't have to go back to that problem. You don't have to go reading through all that information. Now you have everything written in your setup that you need. Okay? So, how about getting up to this point? Is anybody lost? Just think, I don't know what variable goes where. I could just as well as be speaking German up here. Does anyone have that feeling? And maybe it's one of those, we don't want to do that in front of our classmates. We don't want to ask that question. Well, it's one of those things. Please, find someone to help you. Come and talk to myself. We're available to help you do that. Okay, so if that is the case, what is the next thing What can you solve for in all this information? Do you think? We have an acceleration and a time. Can we solve for any velocities? And if you're looking at that thinking, well, I don't know. Well, let's possibly write some of this information down. Okay, we have an acceleration equals, we have an acceleration, we've got a time. Do we have these two variables? No, so we can't start out with this formula. Does it say that that bull started from rest or from 0? No, so we don't know the initial velocity either. Okay, so the formulas that we have so far, so if we don't have any one of the velocities, this formula isn't going to help. You've already established that we don't have enough information for this one, but what does this formula tell you? Do we have 2 of the 3 variables? Yes, we do. Okay? So, what does this formula tell you to do then with the information that you have wrote down? What does this formula tell you to do? Yeah, well, we got the product. It's right here. Yeah, we can solve for the final velocity with this. Okay, so with that, we know what the product is because we wrote it down right here, 3427. So what does that equal on our right-hand side? 820 times what's left over in this equation? Final velocity. Okay? So now it's looking more like an algebra equation, correct? And I think probably, or perhaps part of the problem is taking the written language part and getting that written into an equation. Because now that you've got it this far, now we know what to do, correct? Because we've got velocity final next to 820. So we got to get this final velocity by itself. So how are we going to go about doing that? Just tell me. Yes. In other words, we're going to divide this side by what? Because you said you want to divide by the mass. So what do we do to this side then? Yeah, same thing. Because now these have canceled each other out. Okay? So that tells us that the final velocity then equals whatever these two are in what reference to one another? Divided by. And what does that give us? 4.18. And labeling is what? It's a velocity, so it's meters per second. Okay? So now we've got a final velocity. Our acceleration is still in our setup. We've got that variable. We know it was we know it was 2.1 seconds. So now what can we do with this equation? Solve for initial velocity, because it's asking how fast was that animal or how fast was that bull moving initially or when it started. Okay? So what we're going to do now, okay, let's do what the formula tells you to do, is take the acceleration, which is what? Okay? So what does 1.10 equal on the right-hand side? 4.18 minus the initial velocity okay? So how many of you are maybe looking at this and that, yes? How many of you are maybe looking at that and saying that fraction just looks terrible? Just one? Okay. That's pretty good then. So then the rest of you are telling me you know what to do next. Is that correct? Well, now all of a sudden we're going, well, maybe, I don't know. And I know, I understand, it's just human nature. We don't want to ask any questions. We don't want to do that in front of our friends. That's something we certainly want you to do. Okay? I think this will help make it a little more clear because we've done this before. Are we changing the value of 1.10? No, it's still 1.10. You can even punch in your calculator. It's still going to say the same thing. Okay? So, what happens if I take 1 times 4.18? We're going to get the same thing. So 4.18, what about minus VI? What's 1 times minus VI? Okay, so we're still subtracting the initial velocity. Okay, so now, if we cross multiplied here, what are we going to do with these two numbers? We're going to cross multiply. Okay, so what's 2.1 times 1.10? These two times each other are 2.31. Okay. I was thinking. Oh, okay. Yep. 2.31. That's right. So now as we're looking at that, do we know what the initial velocity is yet? No, we don't. How are we going to get that VI all by itself? Now this is using algebra, and you just haven't used it in this sense. Yes? Yes? Okay. So we want to get this guy all by itself. We're not multiplying, we're not dividing. Okay, so we got to get this off of this side. So you said subtract this over, correct? Yeah, that's right. So we want to subtract 4.18. So what do we got to do to this side then? What happens to these two numbers? They cancel each other out. So what's left over on this side? Negative VI. What does that equal on this side? Is that bad? Because what did we say about velocities? All of them are what value? Positive. Well, we got a negative value up here. Yes? That's a different way of saying it, but that is correct. Yes, you can do it one of two ways. Okay? You can say we're going to divide each side by -1, or you can multiply each side by what? What happens when you take a negative times a negative? It makes it positive. So if we take each side times -1, all All velocities are positive. Now it's positive. Okay? So should you look at that and say, gosh, I don't know if that's right, 1.87? Well, what happens if you take 4.18 minus 1.87 and divide by 2.1? What would you guess you're going to get? That value right there. Okay. Now, this is this is probably the hardest problem that you have done up to this point. Is that correct? So, would this be terrible if this was going to be handed out today and we hadn't gone over anything like this before? Would that be terrible? For some people, yes. Maybe other people, no. But maybe by choice, how many of you feel that you are working to your capacity and I'm doing everything that I can to be successful? Show of hands. Okay. So if your hand isn't up, then you're saying there's a little bit of work that needs to be done yet. And that's fine. Okay? So with that, is anyone looking at this saying, oh my gosh, there's someplace else I'd rather be? Now I'm guessing there's probably going to be a lot of heads nodding. Yes. Okay. All right. So with that, the last 10 minutes are yours. Okay. So as you look at this, what does it say about the rest of this week? Okay. So you do. Is it due tomorrow? No. Okay. How many of you feel from prior examples or prior experience are going to do this now? Write down information that you know. How many of you think, it's probably a pretty good idea that I should probably show what I'm doing on here? Or how many of you may be thinking, well, we're just going to watch someone else do it. I'll just copy it down and then I'll be done. Is that a good idea? No, because if you're getting really high grades on daily work, and then we have this here where you just totally bow out, what should someone on my side of the aisle or someone in my shoes, what should I think? Not something that I'm going to do, but what's something that I should think? Maybe they're not trying. What else? And maybe they didn't know. So you're pointing out things that maybe some of your classmates maybe do, maybe they don't. Okay? If they don't know, if they're not trying, there's opportunities to try to not do that. Okay, that's my point. Some of you have a vocab quiz to take yet. We will pick up with this on Thursday, okay? Because we're going to review more problems. Because tomorrow, what do you get to do? You get time to work on that. Notice it doesn't say it's due tomorrow. I don't like doing things that way.